Ever wondered how an AI like ChatGPT can just talk? How it writes poems, debugs your code, or has a conversation that actually makes sense? Well, the answer goes back to 2017 and a total game changer called the Transformer. Today, we're going to unpack the story of this incredible breakthrough and see how it completely rewrote the rules for artificial intelligence. But to really get why the Transformer was so huge, you have to look at the problem it was built to solve. For years, AI language models, chatbots, they had a really bad memory problem. They were clunky, they'd forget what you said a sentence ago, and they really struggled with the most important part of language, context. So what was holding them back? Okay, let's get into it. The old way of doing things, with models called RNNs and LSTMs, had this fundamental bottleneck. They were designed to process language word by word by word in a straight line, and that created a massive context barrier. Imagine trying to read a whole novel, but only through a tiny keyhole. That's kind of what it was like. By processing one word at a time, these older models would literally forget the beginning of a long sentence by the time they got to the end. And this one-at-a-time approach wasn't just forgetful, it was painfully slow to train. Everything had to wait its turn. Progress in AI had basically hit a brick wall. And then 2017 happened. A paper from some researchers at Google dropped called "Attention is All You Need," and it changed everything. They basically threw out the old rulebook and introduced this radical new idea for how an AI could actually understand language. The secret sauce, the core idea, was a mechanism called self-attention. Instead of going word by word, self-attention lets the model look at the entire sentence all at once. It figures out how every single word relates to every other word instantly. It's like giving the AI peripheral vision for language. Look at a super simple sentence like this one. An older model would have to trudge through 6 words one by one to connect cat with Matt. But a transformer? Using self-attention, it just instantly sees that connection. It understands the most important relationship right away, without getting lost in the words between. So how in the world does it work? Well, you can think of it like a little 3-step dance. For every word in a sentence, first, it sends out a query, basically asking, hey, who here is important to my meaning? Then, all the other words present a key, which is like a name tag saying, this is what I'm about. The model finds the best matches between the queries and keys, and based on how strong those connections are, it creates a new value for that word, a much richer, more contextual understanding of what it means right here in this sentence. But the genius of it didn't stop there. The transformer uses something called multi-head attention, which is like having, say, 8 different experts read the same sentence at once, each looking for different kinds of relationships. One looks for grammar, one for meaning, and so on. And because the model isn't reading in order anymore, they came up with a clever trick called positional encoding. It just adds a little tag to each word that says, hey, by the way, I was the 5th word in the sentence. It's brilliant. So what you end up with is this revolutionary architecture with just massive advantages. Suddenly, training became ridiculously fast because you could process everything at once. The AI could finally understand relationships across entire books, not just short sentences. And its design was clean and modular, which made it the perfect foundation for the absolute explosion that was about to happen. Right, so with the Transformer as this powerful new engine, researchers at places like OpenAI started asking a really simple question. What happens if we just make it bigger and feed it more data, like a lot more? And this is where things just go off the rails, in the best way possible. This timeline of OpenAI's GPT models shows a flat-out explosion. In just 5 years, we went from GPT-1 with about 110 million parameters to GPT-4 with an estimated 1 trillion. And each leap in size wasn't just more power, it unlocked completely new abilities, things nobody saw coming. That jump to 175 billion parameters with GPT-3, that was a real turning point. Because at that scale, something incredible started to happen. The model started showing what researchers call emergent abilities, skills it was never, ever explicitly trained to do, like performing basic reasoning or translating languages it had barely seen. It was like the sheer scale itself was creating a new kind of intelligence. But as it turns out, just being huge isn't everything. A massive, super powerful model isn't actually very useful if it's unpredictable, unhelpful, or just says weird things. So the next big leap was about taking these giants and refining them, making them more aligned with what we humans actually want. This quote just nails the shift in thinking. Before, building AI for a specific task felt like alchemy, a mix of art and science, a lot of trial and error. But the Transformer era turned it into an industrial refinery. You build one massive, general-purpose engine, and then you refine its output for all kinds of different uses. And this was a fundamental paradigm shift. We went from painstakingly creating specialized one-trick pony models for every single task to building one giant general-purpose model that was pre-trained on a huge chunk of the internet. And the result is an AI that can adapt to new tasks with little or no extra training, something the old models could only dream of doing. So how does this refining process work? Well, through some really clever techniques. There's instruction tuning, which teaches the model to follow commands. And then there's the big one, RLHF. That's where humans literally rate the AI's responses, giving it a thumbs up or thumbs down, to teach it what a good or helpful answer looks like. That is the secret sauce that makes ChatGPT feel so natural and conversational. And other tricks, like mixture of experts, are just finding clever ways to make the models even bigger without slowing them down. So where is all this headed? The technology is now moving beyond just spitting out text and into something way more active and tapeable. We're on a new frontier. We are entering the era of the AI agent, and this is not just a chatbot. An agent is a system that can understand a complex goal you give it, break that goal down into steps, and then use external tools like a calculator, a search engine, or its own code interpreter to actually get the job done. You can see this really clear evolution here. We started with these base language models that were basically just fancy text predictors. Then we got instruction-tuned models like ChatGPT that could follow our commands. The next logical step, and what we're seeing now, is the interactive agent, a true problem solver. And this is a total game changer. It turns the AI from a static library of information into a dynamic assistant. Now it can check the weather, analyze your spreadsheet and make charts, or connect to other software to book a reservation. It's the difference between having an encyclopedia and having a personal research assistant who can also run errands for you. And all of this leads to one final, really provocative question. As these AI agents get better and better at planning, using tools, and interacting with our digital world, are we basically witnessing the birth of a new kind of operating system? One where you just state your goal in plain English, and the AI figures out all the complex steps to make it happen. And the foundation for this entire revolution was laid back in 2017 with one powerful, elegant idea: that attention is all you need.